Hello, friends. Welcome to Science Talk. I am your host, Jim Massa. In this video segment, I want to discuss with you basically an evaluation of this past winter, specifically in terms of the Arctic sea ice. And it's kind of interesting because this past winter, at least up here in the Arctic region, was quite cold. In fact, it was the coldest in terms of air temperature, the coldest in 25 years here in Alaska, the second coldest in 46 years, one of the heaviest snow loads as well. But despite all this cold, Arctic sea ice is still at relatively low levels. Okay, so what's going on here? Now, large parts of the U.S. did experience a pretty mild winter. And that's because the cold air stayed pretty much at high latitudes. This was due in part and mostly to a very positive Arctic oscillation. Very positive Arctic isolation basically created a strong gradient so that the jet stream did not waver too much. It didn't dip down. So if it doesn't dip down, it's not going to bring the cold air down to mid-latitude levels. So the fact that the jet stream stayed in a tight zonal flow, the polar vortex was kept constrained to upper latitude. So we froze up here in the north. You guys didn't. Count your lucky stars. So this made for a relatively frigid winter season in the high north, which is good for making sea ice. But this is really interesting. The sea ice, because of the extremely warm summer and fall of 2019, the sea ice formed rather very late in the season. And there was a period where when it got really cold, especially in from the second half of December into about midway through February, where the amount of sea ice extent was actually greater than the 30-year median value. And then it quickly dropped off. So, and by the way, the Arctic oscillation, the calculated index values were the highest positive values ever calculated for that index. So it was quite a strong one. Now, the Arctic sea ice this season reached its largest extent since 2013. It didn't last long. It was still significantly lower than it was 4 decades ago. Okay? 4 decades ago. The Arctic is the fastest warming region on Earth, and there will always be fluctuating winters. Sea ice is in a deep decline. Another thing that's correlated with this, or goes along with this hand in hand, is that there is less and less multi-year sea ice. Multi-ice is ice that basically does not all melt away during the summer months. So it persists, and then comes next winter, it grows and thickens, and so forth. While this year's maximum sea ice extent was a bump up from the last few years, it is still well below average and far from conditions in the 1980s and 1990s, said Zach Labe, a climate scientist and PhD candidate at University of California, Irvine. A quick note here, Zach Labe is now Dr. Labe. He successfully defended his dissertation, and he's now on a postdoc. So he's a really cool guy, and I'm quite happy for him. He's worked his ass off, to be blunt, and you will see some of his work here in some of the slides that I will present. And you're going to see some similarities in some of the other videos I discussed about Alaska's conditions. But this is noteworthy because this is scientific information. This is climate information. But yeah, Zach is now Dr. Labe, and really cool. He's earned it. So congrats to Zach. The bottom line is that the Arctic is still trending over the long term toward less extensive ice cover throughout the year, but with year-to-year variations, which makes sense. And that is a statement from Walt Meyer, senior research scientist at the NSIDC, National Snow Ice Data Center, located in Boulder, Colorado. So here's we'll look at some of the data that Zach was kind enough, and while he was doing his dissertation, he was kind enough to share his data with us. So, really, thanks to Zach, he's making this information available to us. So, this is one from the dated March 23rd, about a week or so ago, from when this video was filmed. The Arctic freeze season has likely ended. This year's sea ice extent maximum was the 10th lowest on record. And this is based on a JAXA data set. The winter's large-scale circulation was dominated by a record-breaking positive phase of the Arctic Oscillation. So let's take a look at this chart here. And let's see if I can pull this up to make it larger so we can view it. And you see he tweeted it out. There we go. All right, let's go even larger. Okay, so what are we looking at here? We're looking at the extent, which is in 10 to the 6th. That's 1 million square kilometers. Okay, so this would be 14 million square kilometers, 15, 16, so forth. So the white line that you see up here is the mean from the 1980s of the extent. This, I guess you call it turquoise, is the 1990s mean. This blue is the 2000 mean. The purple is the 2010s mean. And the red is this year, 2020. So as you can see, and he had some comparative locations from other years included in here, one-off observations, if you will. But as you can see, through basically going into, the end of March into beginning of April, from when he created this data, it's in between the 2010s and the 2000s mean. But nowhere the extent that we saw in the 1980s. Nowhere near the extent. We're talking, basically 13.7 to maybe 14.2 times 10 to the 6 square kilometers. Okay. Compare that to, almost 15.5 million square kilometers in the 1980s. Quite a significant decline in sea ice. Okay, so there's that graphic. 2020 maximum sea ice extent is the 11th lowest in the 42-year satellite record. Okay. And this is a little GIF of a video. Let's see if this will, yeah, that's kind of what you're seeing there. And, bringing it up to, here's the 2020 right there. That's that level. And you can see how it's been declining. This starts from 1980, 85, 90, 95, 2000. So each of these hash marks are 5-year intervals, in case you can't quite see it. And as you can see, it's been a steady decline. Now, the cyclical aspect of it is due to seasonal variation. But if you were to put a regression curve through this regression line, you will have a negative slope, indicating decline. And by the way, when you go back to this data here, let's going to pull this up before I forget to. When you look at this, you can say, why does the sea ice extent seem to be greatest in March? Very simple. The ocean lags behind what the atmosphere is doing. Don't forget, you have the specific heat of water. It takes longer for water to heat up, but it also takes longer for water to cool down. So in the June, July, when the sun, when you have the most solar radiation reaching the surface, at least in the northern hemisphere, It's heating up the water, but it takes some time for the water to get its warmest temperature, which for the ocean is in September. So we expect to see sea ice extent the lowest in September. Then the planet's cooling down, at least in the northern hemisphere, so you get to autumnal equinox, and then down to winter solstice. Then the water lags behind in its cooling down, such that by the time you get to March, that is what's called the ocean's winter. This is why you typically see maximum sea ice extent in March and minimum in September. So it's roughly a 3-month lag time from 3 months from when you have the warmest air temperatures in the northern hemisphere to when you have the warmest oceanic temperatures in the northern hemisphere. 3 months from when you have the coolest air temperatures in the northern hemisphere to 3 months later, coolest oceanic temperatures. And of course, cooler the ocean water temperature is, it promotes growth of sea ice. So I wanted to explain that before I forget, but I wanted to explain why we typically see the maximum sea ice extent in March. Okay, so there's a little GIF showing you the overall decline over the decades. So even though it was cold Arctic winter, the maximum largest amount of sea ice was the 11th lowest in 42 years of satellite record keeping, but it was the highest in 8 years. It doesn't in any way indicate a rebound, but rather year-to-year variations, which we expect to see, said Dr. Meyer. Part of this increase for this one time was due to the highest recorded positive values, not recorded, calculated positive values for the Arctic oscillation. Cold winters largely caused by the well-known fluctuating weather pattern called the Arctic oscillation. I did make an extended video discussing the Arctic oscillation. Please check that out if you have not seen so already. This year's zones of high pressure below the Arctic kept the cooler Arctic air and the polar vortex pretty much in place. This meant an increase in sea ice, but nothing extreme. It's dark in the high north over winter, but overall the Arctic has to deal with what's called a sun-related cycle that depletes the ice, called the albedo effect. Now, if you have sea ice, any solar energy that reaches the surface will reflect off the sea ice. That's albedo. So that heat energy is lost to space. That's what keeps the northern latitudes cool. That also keeps the planet cool. But now if you start having more and more open water, because the ocean temperatures are warming up, then you don't have the ice, you have liquid water. That water now absorbs that heat energy, further warming the water. And then that water now gives off its heat during the cooler months, which helps moderate the weather and the air temperatures in the local regions, but also delays the onset of the sea ice. But with that absorption of the heat energy, you do not have that reflectance of heat energy back into space. You start warming the Arctic, which then in turn starts warming the planet. What happens in the Arctic does not stay in the Arctic. That's part of that's one of the mechanisms, not the only mechanism. That's one of the mechanisms as to why the Arctic is the fastest warming region on the planet. It's the sea ice, or the lack of. Bright white sea ice melts often due to warmer air temperatures. So you have large swaths of dark ocean exposed to absorb more heat from the sun, which warms the ocean, turn melts more ice. It's a positive feedback loop. By the end of summer, this leaves sea ice profoundly melted before each winter begins. And we're seeing this. We're seeing this with less and less sea ice extent. Basically, over the last 40 years, I can give you a summation of what's happened to the Arctic sea ice. It freezes later in the year. It melts earlier in the year. So its existence is a shorter duration. It is also not as thick, which is related to what I said earlier on about reduced multi-year ice. And it does not extend as far south as it used to be. So if it does not extend as far south, that means that leaves you more liquid water to absorb that sun energy. And that's basically what they're saying here. More sun energy is absorbed. That heat in the water will melt whatever ice is there, prevent whatever water it is there, because it's warmer, it can't readily freeze. And don't forget, you have seawater. Seawater does not freeze at 0 degrees centigrade Celsius because you have solutes in there. You have a phenomenon called freezing point depression, where the addition of solutes into the solution lowers the temperature at which the water will freeze. So basically, that is a function of the salinity. Depending on the salinity, salt content will determine at what temperature oceanic water freezes. Now, in the Arctic, there is a lot of freshwater input from glaciers and stuff like that. So it might freeze at, say, -1 or -2 Celsius, whereas the Pacific or Atlantic might be cooler, -3, -4 Celsius. On the flip side of that, when you have salt, when you have salinity, then you have what's called boiling point elevation, where the water will now boil at a higher temperature compared to fresh water. So that's another thing to keep in mind. So you have all this heat energy in there, in addition to that, it takes a cooler temperature than what people would normally think of as when water freezes in order for the water to freeze. So that's even more heat that has to be extracted, and it's done what? The water has absorbed that heat. So the liquid water is going to linger much longer before it starts to cool down sufficiently to form ice. Another contributing factor as to why there's less and less multi-year ice is what's explained here. The warm water melts more ice. So any multi-year ice is going to be melted out. The 13 lowest sea ice extents in the satellite era have all occurred in the last 13 years. Think that's a trend? Okay, Rick Coleman. He's someone I worked with at the IARC. Really cool guy. He and Brian Brettschneider are our Alaska weather guys. They kind of do it everything. And he in particular looks at the Bering Sea ice. As he states here in the tweet, Bering Sea ice extent has declined more than 35% from its March 12th maximum. March 25th extent is the fourth lowest in the 42-year NSIDC satellite era. Big losses, Gulf of Anadyr and Southeast Bering. And as you can see here, let me see if I can enlarge that. As you can look here, 2018 was a particularly low year. But here's 2020. You can see that it's still pretty much lower than, let's see, only maybe 1996 is about at the same level, maybe a little less. But really, it's still, even though it came up a bit, it's when you look at the overall scheme of things, the overall data trend, it's still one of the lower ones happening here. And this is what the area that they looked at here. Gulf of Anadyr is here. Here's the Bering Strait, Bering Sea, Chukchi Sea, and then the Beaufort Sea. So this is the area in red is what's considered to be the data collecting region. That's what the satellite was looking at. Now, ACCAP is the Alaska Center for Climate Assessment and Policy. I've discussed this organization in some of my other lengthy videos discussing Alaska weather and climate. So you can see here, yes, it came up a bit, but it's still low when you look at everything else and when you take it in its perspective. Okay, and let's see, more from Zach. Dramatic decline of sea ice cover in the Bering Sea near Alaska during the last week. This is a result of change in weather conditions. That is southerly winds. Also, when the Arctic oscillation oscillated from the very strong positive to the negative side of things. So, and then with the southerly wind, then you have a slight breakdown in the zonal jet stream flow to more meridional. When you have meridional flow, yes, it brings the cooler temps down to mid latitude, but the flip of it is that warm temps infiltrate higher latitudes. And what happens is that the pressure and temperature gradient are weakened. So now the jet streams flows at a slower rate. So if there's any weather systems riding on the jet streams, they may linger. And if it's a rain or snow event, extra precipitation will be the delight for those on the ground below. So again, let me pull up this graphic here. And now basically these are all these squiggly lines are all individual years. Okay? 2020 is in red. And as you can see, it's pretty much in the median, about midway. But now when you look here at the basic end of March, beginning of April, it's actually towards one of the low points. And this is pretty much when you have open water. Right? September, that is the ocean's summer. And we start to cool down, and then the ice builds up again. I think 2019, I think this might be 2019 right here. The ice started forming a little later in the year. And again, the extent is in 1 million square kilometers. Okay. And then going month by month. So we can see, yes, there's going to be a lot of variations, and we see this from year to year, but we can see some sort of consistency in the pattern. Here are some of the warmer years. I think this is hard to really match up the colors, but I think these two might be 2018 and 2019. Some of the very low sea ice extents, which agrees with the last graphic I just showed you from Rick Toman. But you can see what 2020 is doing. It's kind of taking a dive down. The median's about here. So for a while in February, it was above the median, and then it just dropped because, well, warmer air, warmer seawater started moving in. The ice started melting. So, on top of the Arctic's continually warming trend, fluctuating weather will always play a role in shaping the extent and volume of sea ice. This will lead to bumps, dips, etc. Remember, okay, weather is what's happening right now when you look out your window. Climate is very long-term average of the weather. Changes in daily weather conditions will play a major role in the evolution of Arctic sea ice, says Zach. For example, storms and winds have decimated sea ice in the Bering Sea over the last week. There was a period when the level of the sea ice for this winter was above the 30-year median level. And then you had storms, winds, warmer temps coming in, and it, as we just showed here, it tanked. The amount of sea ice extent dropped dramatically. Big picture remains clear. Climate situation remains unchanged. Earth is relentlessly warming. 19 of the last 20 years are the warmest on record, and the Arctic is dramatically changing. 19 of the last 20 years. Humans are doing this, folks. Humans are doing this. And it's just now finally everything is coming together that we're now seeing the signals. And we're now seeing exponential increases in the effects instead of linear. So temperatures are warming up faster and faster. The ice is melting overall faster and faster. Permafrost is thawing faster and faster, etc., etc. And this can be tied to humans burning fossil fuels. So I wanted to bring this with the story to you that what's happening in the Arctic sea ice, especially after this winter, which was kind of a nasty one up here. But even with this bit of a nasty one, as we can see here, the Arctic sea ice extent was not that great when compared to the data set over the last 4 decades. And the two lowest years are 2018, 2019, which these two lines right there on that graph. So there you have it. But remember, what happens in the Arctic does not stay in the Arctic. It will affect the rest of the planet. Hope you found this interesting. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.